was with our ARC chairman, ma'am, in the Golden Temple.
Oh, very good, very good. He's joining today. Is he
Sir
coming?
is here, ma'am. Sir is
Doctor,
here.
good evening, everybody.
Oh, good evening, good evening.
President, good evening, President.
Good evening, good evening.
Doctor, sorry
Good
to
evening,
interrupt you,
sir.
Doctor.
Yeah,
We are live now, Doctor.
okay. So shall I start?
Yes, ma'am.
Good evening, everybody. At the outset, I'd like to thank all of you for joining us this evening. On behalf of Tamil Nadu Ophthalmic Association, it's a great pleasure to welcome all of you. We all know that AI in ophthalmology is fast developing, and ophthalmology is basically a digital-oriented field. And we are now at a threshold. We not only predict diseases, we are also able to use them in different formats. As you're going to see today, we have some excellent faculty here from both nationally and internationally. And I'm really thankful to Prasanna for putting this very interesting webinar, because this is going to be the order of the day. What we thought was futuristic is actually becoming the standard of care. And in a matter of time, AI will be in every aspect of ophthalmology, if not in other medical fields as well. And I would encourage all the audience to, if you have any questions, please put them in the chat box, or you can send the questions to one of us, and we can have it as part of the discussion. And we're all looking forward to a great evening together. And my welcome once again to the international panelists for taking their time off, probably at a very inconvenient time, and being here with us. And once again, welcome you all for this wonderful webinar. We can move on to the next.
Yeah, thank you, ma'am. A few words from our beloved ARC chairman, sir, Ravi Shankar, sir, before we move into the webinar.
Vanakkam, namaskar, and good evening to everybody. It is indeed a pleasure to be here in the Task Force AI program. And I feel Madam President and myself, we are very happy and fortunate to have such a wonderful task force who are doing such a great job. I don't have to mention anybody's name in particular. It's a great job done by you. And every webinar, every program, we are learning a lot from you guys. Thanks a lot. And I would not waste much time, but I would like to say only one statement. This is an artificial intelligence program. As Madam President said, it's the order of the day. But at the same time, the faculty, the speakers, and the entire gamut of people sitting there in their own respective chambers are people with natural intelligence. They're all brilliant, natural, intelligent people. So they are going to tell us about how we can make use of artificial intelligence in our own practice, our own life. Thanks for the opportunity. Thank you.
Thank you, sir. Before we move on to the event, a quick word on the activities of the TNOA Digital Task Force. And today here we are for AI in ophthalmology. So this was one of the brainchilds of our President Sujata ma'am, which was kicked off within 3 to 4 days after the TNOA annual conference, along with the support of DC sir, our secretary, and the management committee members. So we had multiple discussions on how we can go forward. Especially one activity was reviving the social media done by Dr. Vinod sir. As you can see, the task force members here and panel and moderators. So the social media, EMR, how we can go about reels, daily quizzes, mentor-mentees, teleophthalmology, editing tools, and whatnot. So social media activation was one such modality which was taken by this task force. And the rapid growth of the Instagram page has been a testimony of the work done by Dr. Vinod sir, especially along with the task force members. And the Spotlight Sunday is one such activity which has garnered a huge number of hits among our members. Moving on to the photo and video competition, which is again being spearheaded by Dr. Madhavi, again, who's also on the panel here, which is one activity which we had more than 50 to 60 submissions in the photography category and many more submissions in the videography category as well. And this team has brought about many creative campaigns, including the flyers that you see today, and on eye donation and multiple pujas that we have today, along with editorial and academic content, which that you are seeing has been managed by the task force. And archiving is one such modality that Madam President wanted us to focus on. And we are closely working with Team Numerotech, along with the dynamic members like Pranesh, Samir, Prabhu, who are all here to speak out their activities as well that we are doing as a team together. And operations and distributions, especially through WhatsApp, Instagram, and Facebook, has been very active. And the deadlines has been met in a very timely manner. And even the TNOA Times is one that we are working on, along with the newsletter from this particular committee, which is again spearheaded by Sujata ma'am, DC sir, as well as Ravi Shankar sir. So without much delay, here we are today for the 4 talks and the panel discussion by this elite team. And thank you, ma'am, Sujata ma'am, President TNOA. Thank you, Ravi Shankar sir, ARC chairman, for this wonderful opportunity. And myself, Prasanna, and Niranjan. Niranjan has again been another pillar of this event. He has done almost all the back end work, 80 to 90% of the work. The ideas though were mine, but the execution was predominantly Dr. Niranjan's, and he deserved due credit for it. And I would like to hand it over to Niranjan to invite the first set of speakers and the panel.
Thank you, sir. So it is indeed my privilege to introduce the panelists for today. And first up, we have Dr. Aditya Varman, sir. He is a cataract and refractive surgeon and the medical director at Umai Clinic. He has several accolades to his name, and he is a well-renowned refractive surgeon, not only across the state, but across the country and worldwide as well. We are very happy to have you with us, sir. Next, we have Dr. Anujit Paul, who's currently a consultant of cataract and vitreoretina at BBI Foundation, Kolkata. He is a recipient of several publication awards and also a very active member of several ophthalmic societies. Next, we have Dr. Madhavi Ramanatha Pillai. So she's done her long-term fellowship in glaucoma from Arvind Eye Hospital, and she's renowned for having backed several travel grants, and that's her niche and area of specialty. And she's a very well-renowned glaucomatologist, both at state, national, and international levels. And next up, we have Dr. Vinod Arunachalam, who's a medical director of Vinod Eye Care Hospital and founder of Trichy Glaucoma Foundation. And sir is again a wonderful glaucomatologist and a managing committee member of TNOA as well. We are very happy to have you with us, sir.
Yeah, so making your own AI it's going to be the first topic. I would like to call upon Dr. Vinod sir and Dr. Madhavi ma'am to introduce the speaker and the panel respectively of the first 2 sets.
Yeah. Thank you, Dr. Prasanna. So it is my privilege to welcome Dr. John Davis Akara, who is a glaucoma, cataract and refractive surgeon currently at the West End Eye Hospital and Chaitanya Eye Hospital, Kochi, Kerala. So he has presented in various state, national and international conferences once again, and has a lot of paper, poster, video, innovation awards to his credit. And not only that, he is also an innovator who has innovated his own foldable fundoscope, virtual reality, perimetry, whatnot. The list goes on. So once again, it is our privilege to have Dr. John Davis Akara with us. Over to you, Dr. Vinod, for introducing the international panelist.
You're on mute, sir.
Thank you for the opportunity, Prasanna and Madam. So we are happy to have the international panelist, Dr. Sagara Padirajay from Sri Lanka. He is a consultant ophthalmologist at University Hospital, Badulla, Sri Lanka, and he has completed MBBS from the University of Colombo and MD in ophthalmology from Postgraduate Institute of Medicine University of Colombo. And he had a post MD clinical fellowship in Royal Invincible Hospital, Glasgow, and a vitreoretinal fellowship in Oxford University. And he has a research interest in keratoconus and atropine and myopia at the University of Badulla, Sri Lanka. We are happy to have you today. And our another panelist for the day will be Dr. Amit Kumar Yadav, who did his MD from BA Cornwall Lyon Center of Ophthalmology. And his current role is a founding member and secretary of Young Ophthalmologist of Nepal, as a joint treasurer of Nepal Medical Association, and executive member of International Society of SICS. And he is a consultant ophthalmologist at Janaki Eye Hospital. And he had a lot of publications and attended a number of conferences, and the participation is huge. We are happy to have you as a panelist today, sir. Over to you, Prasanna.
Yeah, John sir, let's start.
So thank you once again to the Tamil Nadu Ophthalmic Association. Thank you, Dr. Sujata, Dr. Ravi Shankar, Dr. Prasanna, Dr. Niranjan, for putting together an awesome, interesting webinar. So I will be talking about how you can make your own AI, and this I'll be sharing a video of myself, what we had done earlier, in which I will teach you how to make your own AI. So I think I'll just share the video, then let's discuss it. Is my screen visible?
Yes, yes.
Okay.
Yes.
Play. Dr. John Davis and Dr. Anju Kriakos present. Build your own artificial intelligence software for free to diagnose retinal diseases. The authors have no financial interest in this presentation. In movies, artificial intelligence is depicted as powerful, good, or evil. But is this fact or fiction? AI is everywhere in modern life. Let us look at the definitions of artificial intelligence. It is a simulation of intelligent behavior in computers, and machine learning is where it automatically learns and improves from experience without being explicitly programmed. So where are we now? The fourth industrial revolution with the cyber-physical system. Research and publications on AI in medical science is undergoing a rapid surge now. Various subspecialties of medical science use AI. Not only ophthalmology, radiology, dermatology, cardiology, pathology, oncology, pediatrics, endocrinology, gynecology, and so many more. There is a lots of imaging and big data in ophthalmology. Slit lamp photographs, retinal fundus photographs, optical coherence tomography of the anterior segment and retina, fluorescent angiography, A scan, B scan, corneal topography, intraocular pressure values, refraction and spectacle power, visual fields, and so much more. Ophthalmology has several diseases which are being analyzed by artificial intelligence, such as diabetic retinopathy, glaucoma, age-related macular degeneration, retinopathy of prematurity, retinal vascular occlusions, keratoconus, cataract, refractive errors, retinal detachment, analyze the progression of squint, and much more. AI is used for IOL power calculation, Hill RBF and LADAS formulas, and planning squint surgeries and anti-VEGF injection. Research from Google's Verily Health Sciences division showed that a single fundus photograph can be used to determine the age, gender, smoking status, HbA1c value, and BMI of a person. You can also detect cognitive impairment, dementia, Alzheimer's disease, stroke risk, and cardiovascular risk. This is an article about the role of AI in ophthalmology that I published in the Kerala Journal of Ophthalmology. CyberSight website from Orbis allows you to analyze fundus photographs with an AI for free. Finally, let's get started with building our own AI. On the right side are test fundus photos taken randomly from the folders on the left. So on the left, you see the ARMD folder, and you see the test photo is different. And here is the BRAO folder, and that's a CRVO folder, and see that this fundus photo and this fundus photo are different. They look quite similar. We'll come into that later. This is the macular holes, the retinitis pigmentosa, and subhyaloid hemorrhage. Let us start building the AI. First, you need to go to the teachablemachine.withgoogle.com website, and once you get to that page, click Get Started. You can open an existing project from your drive or from a file. There are three types: image, audio, and post project. We'll be doing an image project, and we'll be taking standard image model. Embedded image model is for microcontrollers. So first we have the classes. So we first name the class and put the particular image data into that class. So that is the ARMD class. Now the second class, I don't know what it is. So let us first put the images, and then let's see now. Yes, BRAO is there. So I took this folder full of BRAO photographs, and now I name that as BRAO. So once that is done, I continue in the same way and add a class for the other image categories. So now I'm going to insert one for the next one, which is a BRVO folder. And what is once that is entered, I name the class as BRVO, and so on.
A few minutes later.
Now I have completed subhyaloid hemorrhage, retinitis pigmentosa, macular hole, and other classes. It is time to start the training. So in this, I can change some parameters. I increase the epoch to 200, and let's see if that is enough. Spoiler alert, it is not enough. Now that the training is going on, we can look at some of the other settings and understand what these are. So there are epochs, batch size, learning rate, but also note that you should keep this open. You should not close this tab. So while the training is going on, batch size is the number of images that are simultaneously trained. Learning rate is usually kept at 0.001. Epoch is the only setting that you really need to change. Oh look, the training is already complete. So I switch over to the preview. I select file, keep the input to on, and select a file from the test images. So I go to the test images folder, and these are all the test images. I'm going to select one of these, say the subhighlighted image. Note that these are not there in the training images. The AI is confused whether it is a choroidal rupture, CSCR, or a subhighlighted hemorrhage. Finally, I ended up removing many of the classes and increasing the epoch to 5000.
2 hours later.
After running the epoch for 5000 and reducing to just 6 classes, it worked out. ARMT, BRAO, CRVO, macular hole, and retinitis pigmentosa, and subhighlight hemorrhage. Finally, I opened the preview again to file, and first turn the input to on and select a file from the desktop, and I go to the test images and check ARMT, and now it has detected it at ARMT 99% certainty, and even this one, it is detected as BROO with a very high level of certainty. And let's see the others also, that is a CRVO 100% certainty, because there's a very similar image in the training set. And there's a macular hole which is 99% certainty. Another one, let's see the retinitis pigmentosa. It's getting confused between CRVO and retinitis pigmentosa because that is the structure of the lesions, the spread of the lesions. And this is a subhighlight hemorrhage, a very good certainty. And note that all these test images are not in the learning data. To export it, you can click export model, and you can export it as a TensorFlow JS or an actual TensorFlow Python script or a TensorFlow Lite to put it now a microcontroller. Let's go with the TensorFlow JS and upload it onto the cloud. So onto a website supported by Google for free. It takes a bit of time to upload the model, and now the cloud model is up to date. And if you look up there, there is a link to the cloud model posted on Google's website. I copied the link, and this link can be shared to anybody. So once you share this link and open it, it opens this, and I open a file, input on, and select one of these test images or any test image, and it will be able to detect what that is with a very good amount of certainty based on the training data. So that is all, folks. Hope this inspires you to create your own AI for free. Thanks to the director and editor, myself, Dr. John Davis Zakara, producer, Dr. Anju Kuriakos, the AI software from Google, and free music from bensound.com. Thank you.
Thank you. Thank you, John, sir. That was totally out of the box. I've seen many of your innovations. I think this is something you have come out very recently, how to make your own AI. So Sujata ma'am, your comments, ma'am, before we go to the
It
panel.
was very excellent. I mean, something which is unbelievable. I was just wondering, is it possible to do it in keratoconus screening also? Because
Absolutely, ma'am. Absolutely. So this one, what Google has given for free, it has some restrictions. That is, the resolution of the image is limited. The number of data sets is limited. But this is how all basically all the basic image processing AIs work. So if you want to have an AI built for yourself and the resolution of the images need not be that high, you could use the keratoconus training on this as a first prototype.
Yeah, okay.
You can definitely do that.
Try that.
John, sir, you want to take the epoch question once again for the attendees?
Yeah, so epochs just refers to the number of the one single pass through the entire data set. So all these machine learning programs they learn with every pass, every generation it passes through the data, it keeps learning. So the number of times it goes through the whole data, that is how it learns. So if you put 200, that was not enough, so I had to increase it, and once I increased it, it was able to learn. So you might have to tweak some of those settings. You might have to find out what is a manageable number of epochs you can put so that your it finishes in your timeline.
Thank you, sir. Handing it over to the international panelist for your comments, Dr. Amit and Dr. Saga.
Yeah.
Thank you,
Thank you,
sir.
Doctor.
First of all, let me thank the Tamil Nadu Ophthalmic Association and the organizers of this webinar for inviting to be a panelist here. And I'd like to congratulate Dr. John Rice for the excellent talk. And he is a very innovative person. And by looking at this presentation, I also got some new ideas to do. Congratulations. And I think I feel that when I see when I read the story of Aladdin and his lamp as a child, I thought, oh, how lucky I am if I have a lamp like this. I think, but today now, as currently when we take a mobile phone, we have so many AI apps. So all of these are like genies. So if I ask any question from the maybe ChatGPT or something, they give answer it within seconds. So anything, so like that, we can use these AI tools to make the betterment of the human beings and to develop the ophthalmology in the future. And very creative idea, Dr. John, and thank you very much for the idea. Thanks. Excellent.
Thank you. Thank you.
Dr. Amit.
Thank you, Dr. Prasanna, and thank you, Tamil Nadu Ophthalmic Association. And awesome presentation by Dr. Zan. I have a mind out. Actually, what I need to know or understand is this website where you are feeding the data are free of cost?
So the website Learn a Teachable Machine,
Yeah.
that is just a tool. So
Okay.
in that tool, you can put whatever data that you have. So I put some fundus images which I sorted into different categories. So instead of fundus images, as Dr. Sujata ma'am had just mentioned, if you have a lot of slit lamp images, or if you have maybe keratoconus data you cannot use in this, but you have slit lamp images, you put all the slit lamp images which you know are normal in one category. You put slit lamp images of corneal ulcers in one category. You put slit lamp images of pellucid margin in one category. So once you have different categories of your data, you can put all of those into the different classes. That's what they are called. And then you start the training. The AI goes through every class, sees what is the difference between this, and sees what is the commonality between the images in the same group. And once it learns that, next time it sees a new image, it will tell you, okay, among these, this looks like keratoconus. So that is, you can use your data on this free tool. So the tool is the thing. You can use that.
Sure. Yeah. After seeing your presentation, what I was thinking that I should use these tools in my hospital from tomorrow, from right now. We are going to feed some data. What we have collected in the retinal images data, we are going to feed from tomorrow. I think whenever I was just seeing your presentation, I was mind blown out. I think we will start. I think I'm going to start next week after seeing this good presentation. Thank you, Dr. John. Very much impressive.
Sure.
Thank you so much.
In fact,
John, just one question I want to ask you. So when you analyze these retinal images, was the cataract was a problem, or how does it affect this image clarity and the interpretation by the AI tools?
Yes, so I selected only good quality fundus images.
Okay.
So if the image quality is poor, the AI will definitely have difficulty. And especially this particular AI is a very low powered AI. This is a free version. So mind you, right, if you plan to do some basic AI stuff, you use this. But if you plan to do some high-end research, this is just a prototype. Once you get the taste of it, you will go and get the bigger AI tool. You need more powerful, yeah.
Just one question, Dr. Ron. can we feed data from different center, from different hospitals? Can we feed data in our?
Absolutely. So the beauty of this tool is once you generate the model, you can share the link to your model and you can tell anybody, okay, I have made a keratoconus screening tool. Please upload your slit lamp photograph into this, even from mobile. So you take a mobile slit lamp photograph, upload into the particular link which you created, and then it will tell you this looks like keratoconus or this looks like corneal or whatever. So once that is there, you can even do a multi-centric trial.
Okay. Thank you. Thank you. Thank you so much.
Ravi Shankar sir had a question. Yeah.
Prasanna, with your permission,
Yeah, please, sir. Please, sir.
on behalf of TNOA and Madam President, I'm happy to invite the Honorary Secretary, Dr. Chandrasekhar, who's joined us. Welcome, Dr. Chandrasekhar. And
Thank you so much, sir.
happy to see Woyong Zheng from Malaysia. In spite of his difficulties, he's made it over here this evening. Thank you so much. TNOA salutes you and appreciates your presence, Wong. Thank you. Over to Prasanna.
Yeah, a quick comment from our own techie person, DC sir, who has also been a very instrumental person in the digital task force.
Thank you so much, the entire team, Honorable President and Dr. Ravi Shankar sir, our chairman, and leader of this group, Prasanna Venkatesh Ramesh. It is wonderful. You know, John is a very good old friend, and basically this AI is taking over. Now, how much it is going to take over, we don't know. At Arvind, we are also doing a lot of things to help our EMR be, fantastic without any errors, and of course, diagnostic tools. So today you can just listen to the patient, talk to the patient, and within 2 seconds you get a complete review, tell you what to do, and give a plan of action. Except that it doesn't treat. So we are going ahead, and it's nice to see so many young people from across the world. And all the very best for this wonderful program. Sorry I got delayed. Thank you so much.
Thank you, sir. Thank you for your guidance and support always, sir. Back to Niranjan to invite the next set of speakers and panel. Niranjan and Aditya to do the needful.
Thank you, sir. I'll just share my screen.
Yeah.
So the next talk for today's evening is going to be about AI tools to supercharge ophthalmic productivity. And we have the robotic man, Dr. Pranesh Ravi. So he has immense knowledge in this arena of tech, and he's one of the very few ophthalmologists who knows coding. So his CV again runs into many lines, and we've tried to compress it. So we are very happy to have you with us, Pranesh sir. And to join him on the panel, we have very eminent ophthalmologists from across the world. So we have Dr. Ashraful Haq, who is the founder, president of Bangladesh Young Ophthalmologist Society and the scientific secretary of Bangladesh Society of Cataract and Refractive Surgeons. He is the Best Yo Award winner at 36th APAO Congress 21, Best Paper Award winner, consultant refractive and anterior segment surgeon at Bangladesh Eye Hospital and Institute, and executive director at Bangladesh Eye Hospital, Zigatola. Next, we have another international panelist, Dr. Raymond Nelson Regalado, who couldn't join us today evening due to unfortunate circumstances. So we are very missing him at this moment, and looking forward to having him in the future webinars as well. Over to our speaker for today, Dr. Pranesh.
Thank you, Niranjan, for the kind introduction. So I'll just share my slides. Okay, are my slides visible?
Yes, sir. Yes, sir. Please go full screen and we can see.
Yeah, I'll just go full screen. Just 1 second. I'll just close the floating menu and then. Okay. Am I audible? Am I clear?
Yes, sir. Yes, sir.
Yeah. So just 1 second. I'll just optimize my presentation to this. Just 1 second. I'll just optimize presentation to sound sharing so that. Yeah. Yeah. Hi, very good evening to everybody. A big thank you to TNOA President, Madam Secretary, and my dear colleagues who are part of this initiative. I'm really grateful to be presenting here today. So the topic for today is, for me, is AI tools to supercharge your ophthalmic productivity. So myself, I'm Dr. Pranesh Ravi. I'm a cornea and a phaco-refractive surgeon. So I'll be presenting and telling a bit of tips to how to boost your productivity. The first step is to use Gemini to manage your tasks and calendar updation. So basically, every day morning, what I do is I just go through Gemini. So it can, you just have to earmark this thing which you want to do, and it will kind of help you out in managing your tasks, setting reminders, and making your calendars much faster. Sometimes what I do is I just take whatever the itinerary I have and just completely paste it in calendar, and it will easily mark everything in the calendar. So I have my days and my events managed for the month or coming months, and it's really helpful. It saves me a lot of time. So this is something which you can try. The second one is voice typing using Whisper model. This is the model which I trained. The latest model is Whisper 3. I'm yet to train it. So I'll show you. This particular Whisper model works very well. It has a very low error rate. It understands my diction and phonetics, and it works very well. I have trained this model with my own ophthalmology terms, and it is very useful. Yeah, so this is something which I have trained. This model I've trained, and but you need not even have I'm having a very GPU heavy computer to run it locally. You can even use a local API, or even you can press Windows Edge and use the custom Windows voice typing to do this. That also run a very less power hungry AI, and it works really well. It'll, if you have to write a transcript, it really helps you a lot. Whisper model is more accurate, and this model is comparable to the Whisper Dragon, which is used for usually the annotation by doctors, medical professionals in the United States. Next, you can learn anything using Gemini Stream. So, hey Gemini, can you tell me how to change the font of the heading in this slide?
To change the font of the heading in this slide, you need to first select the text in the heading. Then, in the Home tab, go to the font group and choose your desired font, font size, and other formatting options. Would you like me to elaborate on any of these steps?
No, can you suggest me a font which is more professional?
Certainly. Avenir Next, Montserrat, or Leto are often considered professional fonts. Would you like to try any of these?
Can you give me one option?
All right, how about a body?
Okay, so can you spell it for me?
Sure, it's ABADI.
Body. Oh. Okay, so this is something which you can do. You can learn literally anything. You can learn. It's now the Gemini Stream model is trained on most of the basic stuff. Ask to how to. So you can learn Photoshop. Everything you can learn from this, and this is actually extremely useful. If you want to learn something which you don't know, if you're stuck in the computer, you can ask it. You can share the whole computer, and it will be able to help you out. Hey Gemini. So then this is something. If you have a normal notebook LLM, it's fine. If you have a pro model, it is great. So basically what I do is I just upload, I can upload 300 sources. I have the pro version. So what I do is I can clear the doubts on basis of text. You can use internet, but the text is more standardized and it's peer read. So you can, when you have something, when you're reading for an exam, you can always use LLM to get all these notes, and you can make flashcards and mind maps. It's actually very useful for reading, and you can see it is also marked. The advantage of using notebook LLM is it doesn't hallucinate. It just takes the source from the text that you've provided. But usually the problem with AI is it always extrapolates. It doesn't, its understanding of grammar is a bit skewed. So whatever is written is extrapolated. So you should take it with a pinch of salt, but it's actually useful if you want to run through a larger text and get a multifaceted idea about whatever you are reading. So this really helps, and it will be helpful for reading and also knowing about new stuff. So this is something which I created. I just send this to Yosikon. So using Perplexity Labs, I created an application by myself. This is you can do it with text, but if you do it in a code, it's much better. The AI understands it much better. So this is ICL sizing calculator. So I just have to mention the white to white and the anterior chamber depth, and it helps. This actually, rather than helping me, it helps my optoms much because it simplifies it. And this is a refractive surgery decision support calculator for my optometrists who will just do the preliminary after I enter the age, the sex, other ocular history, systemic history, if that is positive, and then talk about refractive stability and all the stuff. Usually profound optoms might not require this kind of interventional modality, but somebody who's amateur, who's still climbing the ladder, this thing will definitely help them, and help them make a decision. It is much more simpler, and you just have to enter the details. This is more lined towards a pentacam, but now in my setup I have Cirrus. So certain parameters you will have to change. That's why I'm just entering the Kmax and I don't enter the BAT-D and the TBI. So additional, and then finally it will give you a full report like this. It'll calculate everything. If you do it through text, it's good. If you do it through code, then it's much more accurate. You can be very nuanced, and it will give you the procedure recommendations, what is more recommended, and all those stuff. So it helps to streamline the process and make it much faster. The pre-op screening. So yeah, that's it. Thank you very much for your patient listening. I really appreciate it. Thank you very much.
Thank you, Pranay sir. Thank you so much.
Thank you.
And I would like to request our panelist, Dr. Ashraful sir, to share his 2 cents on specification.
Thank you very much. Am I audible?
Yes, sir. Yes.
Yeah. Thank you very much. And thank you, Tamil Nadu Ophthalmic Association, my friend, Dr. Prasanna, the Tamil Nadu Ophthalmic Association President, Sujata Madam, for having me here. And this is a wonderful webinar, the AI in ophthalmology. This is the present thing that we all need to know. Basically, AI is not replacing us, but it helps us a lot. And I basically am a very big fan of ChatGPT and DeepSeek. Yeah, in my practice, in my patient awareness task, and even in my right now social media post, I usually use the ChatGPT and DeepSeek. They even create poster for me, like the patient I need to send the cataract awareness or the things of what he need to do and everything after the cataract surgery, after ICL surgery, after refractive surgery, or before refractive surgery, what need to do. That's AI is just creating poster, and AI is just creating a good brochure for me. It's a very good thing. So we all need to know AI, and we all need to use them. AI is not replacing us, but we have to use them for our next ophthalmology make easy for the patient and for both of us. And Dr. Pranesh, it's a very wonderful presentation. Just I want to know that regarding the ICL, what the AI tool is it free, or if I'm also an ICL surgeon, so if I want to make these things for my my team who does this for me, so how can I do it?
I'll send it to you, sir. It's just
Thank you very much.
I've written this code and I'll share it to right away. I've written this code, mounted it on the Perplexity Labs. So this app is locally run under the Perplexity umbrella. So I'll share it to you right away. So basically, I can just order the size immediately, and I need not wait around, go through the table, see what is like. I need not do that. I'll just type it in and it's good. But it's most customizable. So yeah.
Yeah, that's the great thing. That's the great thing, and definitely the ICL sizing and the vault is the very important for us. So it will be great helpful for the refractive surgeon also. Just if Dr. Prasanna, with your permission, just go back to the previous Dr. John Davis. This was an excellent presentation. Just I had one question that is there any minimum limit of entering data? Like if you go for the diabetic retinopathy color fundus, that is the NPDR staging or PDR staging, do you need to enter the minimum number of data to make some AI feasible result? And also, is there any maximum data that how much you can enter? Thank you, sir.
Thank you, Dr. Ashraful Haq. So that's a very good question. The AI doesn't impose any minimum data limits. So even if you put one image, it lets you create create the model, but the accuracy improves with more data. So I put in I think around 10 to 15 images, and with that I was able to get decent AI detection. The model was decent, but if you put in say 100 or 200 images, the accuracy in detecting would increase drastically. So that is definitely important. And this is being a free service, they have some limits on how many images are there per set, and also how many sets there are. I don't remember exactly, but there are limits imposed. So this is what I have used from Google's with teaching. Teachable machine is a free service which has limits, but yes, you can go in for a paid service which does not have limits. Or if you have your own lab, you can probably do unlimited stuff with it. You need
Thank you, Dr.
powerful.
John and Dr. Ravi for the excellent presentation, and thank you TNOA for the excellent webinar. Thank you.
Thank you, Ashraf sir.
I have one more question. I wanted to ask about AI hallucinations. Like, how do we actually prevent that? Because if we are to actually like use AI hallucinations in real clinical practice, then that would actually be not very beneficial to the patient, right?
Yeah, Dr. John, Dr. Pranesh, you want to go for it?
Hallucinations, because if you, I don't, I can even show you an example, but due to paucity of time, because basically, for instance, if an Indian author is writing something, he would have a certain understanding. He would, array a certain words, and the meaning would be understandable to us. But the AI will take it in a literal sense. And if it takes two or more data, and if it clubs it together, then it'll make a slightly different meaning, and it'll extrapolate it. So that is where the problem lies. The hallucination is going to be there. If you want to, get away from hallucinations, if you plan to use AI, the best thing is you have a very strong knowledge with regards to the subject that you're asking the AI. 10 hallucination, then you're not going to hallucinate. AI will, you will not. So that is how you go with it. Because when AI tells me something, I know whether it's whatever it says it's validation or not. So that is the best way to know that the output which has come is having hallucinated or not. But it's always better to read it completely, whatever the output you're getting.
So yes, adding to what, sorry, adding to what Dr. Pranesh mentioned, as Dr. Pranesh showed earlier, you could use Notebook LM if you are using AI to learn about something, because that tries not to hallucinate. It always tries to quote its sources. And what is interesting, it does citation for all the things that it gives you. So it will give you a reference, a citation number, and you can click the citation and see where it got that information from. And that is where you have explainable AI, and we try to avoid the black box of not knowing what the AI is doing. So we need explainable AI, and we use heat maps. So if it's an image analysis AI, the AI will give you heat maps of the places which allowed it to make the decision that this is a particular disease or whatever. So explainable AI by using heat maps. And if you're trying to learn about something, teach Notebook LM is one AI which does not hallucinate. Thank you.
Thank you.
Yeah, thank you. With that, we'll move to the penultimate set, Niranjan. I would like to call upon Dr. Aditya to invite the next set of speaker and the panelist.
Yeah, hi. It's my pleasure to invite the next speaker, Dr. Prabhu Krishna. He's currently working as a medical officer in Aravind Eye Hospital, Madurai, where he's done his residency as well. He's actively involved in clinical practice, patient care, and also is involved in community outreach programs at Aravind Eye Care Hospital. He's a prolific cataract surgeon, and he's also won multiple competitions, including a hackathon. And we can't wait to listen to his next talk on AI in ophthalmology. So the next international panelist that we are going to have in our webinar is Dr. Mia Wood Yiso. She is from Singapore, working at Singapore National Eye Care Center. She's working currently as a consultant there, and it's a pleasure to have her at our webinar. The next international panelist we have is Dr. Nan Ruang. He's a comprehensive ophthalmologist who is practicing in Vietnam. He specializes in pediatric ophthalmology, particularly in ocular plastics, and his research interests include cornea and ocular surface disorders, and he also has done extensive research in AI and its applications. Welcome to our webinar, Dr. Nan.
So over to you, Dr. Prabhu Krishna. You
Yes.
can
Yes. Good evening, everyone. Thank you, Aditya sir, for the kind introduction. And thank you to TNOA for this opportunity. I'll go ahead and share my screen. Yeah. Yeah, so good evening, everyone. I'll be talking today on the AI Copilot revolutionizing ophthalmology presentations. Like our colleague from Bangladesh, Dr. Haq sir said, we must learn to harness AI. AI is not our competition. We must learn to harness it and use it to our best. So a disclaimer, this presentation is partly made by AI. A lot of the infographics and images that you see in my presentation, almost all of it has been generated by AI. So this is my presentation overview. First, we'll have a basic introduction of all the AI models that we have currently, the major ones at least. And then I'll take you through how we can use AI in making presentations, and then how we can use them in video editing. And the most important part is how to generate content from AI. And finally, we'll conclude by looking at a few examples. So this particular image, I think forms the premise of what I'm trying to convey, in that our time is finite, but the need to communicate is ever growing. And I'm sure all of us ophthalmologists, particularly from the developing countries in Southeast Asia, can relate to this. A good proportion of our time every day goes in clinical work, and it gives us only some time in the evenings, mostly to work on projects, publications, and other ophthalmology related communications. So how we can maximize the availability of that time, AI can really help us with that. So what are the current AI models that we have at our disposal? The first is Google Gemini. So Gemini and ChatGPT both are large language models. And so large language models basically refers to a chatbot which has been trained with an enormous amount of text. I'm talking hundreds of millions of words. So it's basically a chatbot which has been trained with an enormous amount of text. And Gemini also has image generation capabilities and video generation capabilities. The image generation software of Gemini is called ImGen and the video software is called Veo. Both of these are inbuilt into the Gemini chatbot. The next most common and the most famous one is, of course, ChatGPT. ChatGPT is a large language model with image generation capabilities as well. The third most commonly used is called Claude. It is a large language model which is supposed to excel in coding and creative writing. And the other tools include tools like Perplexity AI, which is very good for research and research related questions. It's supposed to put out very good answers with citations. And Midjourney is another app which is used for image generation. It's a purely image generating AI and it's supposed to be the best at that particular area. So what are the specific uses of AI in making presentations? The first one is content generation. Then it can also help us with our design and visualization of the presentation, and it can help us practice and deliver the presentation. And also it can help us transcript and analyze and look at some of the post-presentation enhancements of the presentation. So in video editing, the first and foremost, it can be used in script generation and story ideation. So we have to remember that these are language models. So what they excel in is creative tasks. So they're very good in coming up with stories and scripts. And it can also help us in video indexing and timestamp creation. So once you have done the production, this is something that takes a lot of time, where you have to index the video, create timestamps before you upload it. So AI can really help with that. It can also help in creating explanatory animations. So Google Gemini has a software called VO built inside of it, which can create up to 8 seconds of animations for you. And of course, the simplest and one that the AI can do very easily is subtitles generation. You have to upload your script and it can generate the subtitles in all the languages possible. So what is the key to effectively using all these AI tools? We've seen the uses, but how do we get AI to give us that particular use? The key to this is a term called prompt engineering. And believe it or not, prompt engineers are now actual jobs in the IT industry. And as important as coding is, this is something that will be of paramount importance in the coming years. So prompt engineering basically refers to what it is, which is creating or engineering effective prompts which can make the maximum use of the AI. So how can we engineer effective prompts? We'll have a look at that. So this particular terminology is very common in the computer world. It's called GIGO, which is garbage in and garbage out. So what it basically means is any computer model, it can be AI or a coding software, if you don't give it good data to work with, or if you don't give it good content to work with, it is not going to be able to provide you with the required output. So hence garbage in, garbage out. So this we tackle with the help of good and effective prompts. So you have to think of the AI as a little childish robot. It is capable of doing so many wonderful things, but only if you give it the correct direction, it will get you to the desired output. Only if you tell it how to walk through the maze using a good prompt, it will reach the destination. So this mnemonic is something that I want everyone to remember. It's CPRF. So any prompt that you give to the AI, use this mnemonic. And so the C stands for context, P for persona, R for request, and F for format. We'll look at each of this in more detail. So coming to context, you have to give the AI the necessary background to what you're trying to do. Don't assume that it knows what you're thinking. You have to give it a complete picture of what you want to do. So the average prompt, for example, will be explained in detail about diabetic retinopathy. So a good prompt will be, I am preparing a presentation on the clinical features, classification, and management of diabetic retinopathy. And the audience for this presentation is ophthalmology residents and retina specialists. So this is more comprehensive. It gives the AI what you're trying to do and who it's going to deliver it to. So coming to the persona. So what persona means is you have to tell the AI who it should be. This will shape the style and tone of the answer and also the vocabulary. So an example for this is act as a leading retina specialist with 15 years of experience to help create this presentation. So this tells the AI at what level it should be. It's not at the level of an MBBS student. It is at the level of a retina specialist. So hence that will shape the answer it provides. So in request, the single most important point is be specific. You have to set as many boundaries and rules for the AI as possible. And you have to direct it to the point that you want to achieve. Clearly state what you want the AI to do, use action verbs, and avoid ambiguity. So an average prompt will look something like this. Make a 15-slide detailed presentation on diabetic retinopathy and its management. A good prompt will look something like this. I know it's crowded, but provide a comprehensive slide-by-slide presentation layout and include the key points for each slide. Have an introduction, explain the significance of DR, and also cover the clinical features, classification, and management in sequence. And also include a treatment protocol flowchart and add a few slides on the newer generation anti-VEGFs. And it can be up to 30 slides long. So I have told the AI exactly what I need, how big it should be, and in what sequence it has to be in. And finally, the format. You have to specify how you want the output to be structured. This will save us time in reformatting it once we get an answer. So for example, for this prompt, we'll go with generate all the slides in text with the required points for each slide. So now let's have a look at our complete prompt. So I know it's crowded, it's big, but this is what makes a complete prompt. So let me now share, let us put this prompt on both the AI models and look at the live response to it. So this is ChatGPT. I've typed down the prompt on ChatGPT. While ChatGPT's response loads, I've already entered it in Google Gemini. Let's look at what it gave me. So this is the entire prompt. It's reasonably long. And what it has given me is a slide-by-slide layout. It has given the title as DR, a clinical update. The title slide disclosures, an introduction with the epidemiology data. It has also added a slide on pathophysiology, though I did not specifically ask for it. And then it explains the clinical features and of first NPDR and then PDR, and also the classification of NPDR. It also talks about the high-risk characteristics of PDR, and of course DME, the definition of diabetic macular edema. And then it comes to the management, where it starts with systemic control. So as you can see, it's quite accurate. It even shows results from the Accord eye study. And then it goes over to the management of NPDR and PDR, showing the PRP and the role of anti-VEGFs. It also covers some of the DRCR protocols, the role of steroids in DME. As you can see, it's very detailed. It's quite a comprehensive output. It has also generated the flowchart that I asked for. And it has also included the newer generation anti-VEGFs, the brolucizumab and faricimab, and including the trials Hawk and Harrier for brolucizumab, and Yosemite and Rhine for faricimab. So and finally, it shows a couple of cases and concludes the presentation. So as you can see, it's quite comprehensive, and it provides a very good platform for you to make your presentation. In fact, you don't really have to change much, but anything said and done, this is a language model. So it is our duty to verify each and every line that it has generated, because there is a small chance that it can confabulate. So it is our duty to make sure that all of it is in fact true. Okay, so this is the response from ChatGPT. It is still making the response, and it's more or less on the similar lines. It's quite detailed with a similar approach and sequence. One minute. Yeah. So ChatGPT has also produced quite a detailed response. Yeah, let me go back to my presentation. Yeah, so that shows the level of detail to which AI can go to. And for any PG level presentation on broad topics, it will be able to do an excellent job. So prompting saves time. It is better to spend 10 minutes making a good prompt than an hour trying to modify the output. So coming to what are the uses, other uses, design and visualization, practice and delivery, and post-presentation enhancements. Let's first look at the design and visualization part. So first we have these tools which can create your slides automatically for you. These are examples are Slides Go, Slides AI, and Beautiful.ai. But the problem with this is you have to give it every word of the content that you want on your slides. You have to give it the entire content and it will make slides for you. These are not extensive large language models. They cannot generate the content for you. They're very good, but they can make slides. They cannot generate the content for you. That has to be kept in mind. The next two uses are infographics and chart generation and images generation. This can be done quite well by Gemini and ChatGPT. And the important point to note in this is the images that come out of these chatbots, they're very good for non-technical and non-scientific image generation. You want it to generate awareness posters, anything non-scientific, it's going to do a great job. But if you ask it to generate a cross section of the trabecular meshwork or an image of neovascularization of the disc, it is not going to be able to do that. Or it will do it, but it will have a lot of errors. So it's very good for the non-technical or creative generation. That is where it excels. So even for image generation, we have to prompt it in the correct manner, and it has a similar format. Let us look at that. The first one is content. Be specific. Instead of doctor and patient, in this example, use an Indian ophthalmologist in a white coat showing an eye chart to a middle-aged woman in a clinic. So it gives you a holistic picture of what you want the AI to generate. Then mention the style, whether you want it in a realistic style, an anime style, or any of the other styles. You can play with this. And you should set the mood or tone: professional, colorful, soft, futuristic, etc., friendly. And finally, the format. This is particularly important when you're generating images. You have to tell the AI to exactly what format you need, because once it generates, if you ask it to modify to a different format, your image as such will change. It is not going to be able to do a good job. So you have to give it the exact format that you need: 16:9 horizontal or A4 vertical, whether you want a text space to be added. So the format has to be very clear. So an example for a good prompt for this would be an A4 vertical poster, realistic style, Indian doctor, explaining glaucoma, colorful background, and leave a space for text, a bright and professional tone. So I put this on ChatGPT, and this is the image it generated. Just you can see it's quite detailed. If you show this to a random person, it will be difficult to tell that this was AI generated. So I asked ChatGPT to do the same in anime style. And this is what it gave me. A pretty good response again. So then we take things a little bit higher. We asked ChatGPT to create 6 images for patient awareness on glaucoma for use during World Glaucoma Awareness Week 2026. It should be colorful, attractive, informative, and to make 3 out of the 6 in anime or comic style, and to generate it in a vertical A4 vertical format. I used both Google Gemini and ChatGPT for this. And let's first look at the responses from ChatGPT. First, we have the 3 non-anime style images. So as you can see, these are neat, clean, simple posters with excellent captions. Glaucoma, the silent thief of sight. Get your eyes tested today. And in particular, the third one was really nice. The third one was don't wait for your symptoms, showing a eye with a clock inside. Next, moving to the anime style images that ChatGPT produced. Again, it was on the same lines. As you can see, ChatGPT has a relatively simple, neat and clean style with the exactly relevant words. It's not crowded the poster with a lot of words, exactly what you need. And the final image was really interesting. It was quite nice. It's a Indian superhero with an O in the middle, probably signifying an ophthalmologist. So this was ChatGPT's responses to the image prompt. Next, when we look at Google Gemini, Gemini's responses are a little bit different. So as you can see, the posters are significantly more crowded. They're nice. They have a lot of information in them, but they don't have that creative edge that we saw from ChatGPT. it does the job, but that slight creativity factor is lacking in comparison to ChatGPT. And as you can see, there are a few spelling mistakes, if and lee, for, and this is a known fact. AI generated images, there is a potential for wrong spellings. So that is something that you always have to check. And these are the anime generated images from Gemini. These were really good, but as you can notice, there are certain spelling errors. It's got glaucoma wrong in both the places in this poster. The final one was really good though, and it surprisingly did not have any spelling errors as well. So these are the areas in which, with respect to image generation, they excel. Creative feedbacks, creative posters and drawings is where they do really well. Coming to the final two uses, so AI can help us practice and deliver our presentations. It can help us with questions and answers. It can predict the possible audience questions and help us prepare the relevant responses. And also post-presentation, AI transcription of the entire meeting or presentation is something that's very commonly used these days. I'm sure a lot of us have used it in Zoom as well. And also it's used for audience feedback analysis and content repurposing. Like this presentation, I can just convert it to a blog post or a video. It will help me do that. So what the key takeaways from my presentation are that AI is a powerful co-pilot. It saves time, enhances quality, and improves communication in ophthalmology. And prompt engineering is key. It is the single most important takeaway from my presentation. A good prompt engineering and if we learn to make good comprehensive prompts, we'll be able to make the maximum use of AI. And start experimenting with simple tasks. It's not rocket science. The key is to begin, and once we start doing it, I'm sure all of us will be really good at making use of AI. Thank you. Thank you once again. Thank you to TNOA, Prasanna sir, Niranjan sir, and Sujata ma'am for this opportunity.
Thank you, Dr. Prabhu. We'll quickly move to the panelist comment, Dr. Mia and Dr. Han. Over to you for your comments.
Yeah. Thank you for the great talk, Dr. Prabhu. And thank you, Dr. Prasanna and Dr. Niranjan for inviting me to this wonderful seminar. And as a PhD candidate, I'm doing a lot of reading right now. So your presentation is really like give me more insight, and I would like to add up into your great talk with some idea that I am using right now. And about your talk, the main idea of the presentation is the content generation, image prompt, data visualization, and enhancement. And first, we have to understand about the prompt engineering first. So because we will use our wordings, our text to instruct the AI, the ChatGPT Gemini, to understand what we are going to obtain from that. So understand the prompt, how to build a prompt is very important. So I always use the snippet app to save the prompts that I usually use in my workflow. So it could save a lot of time when we interact with our AI, with ChatGPT, Gemini, and so on. And also to reduce the hallucination when we generate the content. I usually go through multiple AI tools. Like first, I go to Perplexity to see how broad is the topic, and then I collect on the articles, on the books, and put it into the notebook LM, and that could help me to gather the things in one place and with the reference, because it have the reference number with the information. And then after that, I put it into the ChatGPT, and So it could give me a lot of ideas because ChatGPT is very creative. It gives us a lot of IT ideas, something good and something not good. But we could have like more creativity in that specific content, and it could be even more creative in generate our content for the presentation. Yeah, and that's it. Thank you for the great talk.
Thank you, sir.
Hi, I have one more question for Dr. Prabhu.
Yes, ma'am.
So I noticed that when I use these prompts, when I'm making posters using ChatGPT, sometimes I get these spelling mistakes. So when I ask ChatGPT to correct these spelling mistakes and then again use like rewrite the prompt and then specifically say, okay, this needs to be corrected, this needs to be corrected. But then it again keeps on generating something more different. And then again, it generates something different. And then I just end up getting frustrated. So sometimes I feel like sometimes doing it myself on Canva or Illustrator, even though it takes time, actually is more worthy sometimes, like it leads to frustration. So because once the image is generated, then the thing is like you can't edit it, right? So my question is like, is there a way to troubleshoot this particular like issue?
Yes, ma'am. Very good question. The most recent versions of ChatGPT do in fact have lesser incidences of these spelling errors. But that said, it can still happen. So one thing that you can do is you can ask ChatGPT to first give it to you in a text format, what it is going to put in the image. And once it has done that, then you can ask it to generate it as an image. And make sure to mention what format you want it in. And as much as possible with respect to posters, the lesser the words, the better. So even in my presentation, when you saw, Gemini used a lot of words, and more words, higher chances of spelling mistakes, basically. So in ChatGPT, if you can instruct it to restrict it to maybe 15, 20 words per poster, it should be able to get it done without spelling mistakes. And you can ask it to generate the text first and then generate the image.
Thank you.
Okay, thank you. No further questions.
Any other questions, Dr. Mia? You have any other questions to Dr. Prabhu?
Thank you for the presentation. It is a great talk, and I would like to share my experience with the AI tool. So I use Microsoft Copilot software to create the wonderful presentation, especially in preparing the foreign lectures. So it can reduce the time, and AI make the slides more visually appealing, and it is very easy to use. And I also learned a lot from this webinar by attending this. Thank you, Prasanna, and all the presidents of the Tamil Nadu Association. Thank you for inviting me to participate in this event.
Thank you, Dr. Mia. With that,
Prasanna?
yes, sir.
Can I add a comment, please?
Sir, please,
Just
sir.
2 minutes.
Over to you, sir. Yeah.
So wonderful talk so far. And as I was listening to Prabhu, I was so inspired. I created a Gemini Pro account. I'm giving a talk next week on anisometropia and anisekonia. So I created some prompts and I got such a wonderful light and some of the new points also. So it was really interesting. And thank you all for this wonderful webinar. It was really live. I could see how beautiful it is. Thank you, Prabhu and John and Pranesh.
Dr. DC, I must also confess, I did the same thing.
That's why, madam, we are the same team.
I think we need more like this because we need these young people to teach us a lot.
So at this time, I would like to invite this team next year to the TNOA conference to give a wonderful, these kind of talks. Basic, what you're talking is just needed for everybody as a 1 hour program. And welcome to TNOA 2026 at Coimbatore.
Thank you, sir.
Yes, sir. Thank you, sir. With that, we will quickly move to the last set of the day, the TNOA Digital Task Force webinar, AI cataract surgery, present and future. So we have another dynamic digital task force member of TNOA, Dr. Sameer Chowdhury. who's also part of the TNOA Times and the editorial board. He's currently finished his MS 2 years back in Madurai Arvind, and he's a consultant there. And he's also very dynamic in UC, and he has 25 publications, 3 book chapters, and he's a high volume prolific surgeon. And he has also trained many residents at a very young age. He has trained close to 40 residents, and he's a multiple award winner in national and international congresses. Welcome, Dr. Samir. And I would also like to call upon Dr. Madhavi ma'am to invite the international panel.
Thank you, Dr. Prasanna. It is my privilege and pleasure to welcome Dr. Y. Zeng, who is with the Ministry of Health in Malaysia. He is currently the president of Malaysian Young Ophthalmologists, and he is a prolific surgeon operating in multiple cataract camps in Malaysia. And he has multiple key achievements to his credit and award-winning surgical presentations. Welcome, Dr. Y. And next we have on an international panel Dr. Zana Yusuf, who is once again trained at the Harvard Medical School, and who is a medical officer currently working at the Treetop Hospital. And she is also a faculty presenter in YOSICON and multiple various international and national level conferences. Welcome, a warm welcome, Dr. Sana. Over to you, Dr. Prasanna.
Samir?
No.
Screen is all yours.
Just 1 second. Yeah, are my slides visible?
Yeah.
Yeah. Very good evening to one and all. At the very outset, I would like to thank the entire team of TNOA for giving me this lovely opportunity. And as we would have seen from the previous talks that, artificial intelligence is coming in a very, very big way, and its role is being very extensively extrapolated to medical healthcare as well. So before we move on to the topic like AI in cataract surgery, I would like to show a very brief glimpse of what we have achieved at Arvind Eye Hospital in the field of diabetic retinopathy.
You know how they say there are 2 certainties in life, right? Death and taxes. Can't we get rid of one of those? See, 100 years ago, life expectancy was only 45. Can you believe that? And then by the 1950s, it was up to 65, and today it's almost 80. Tomorrow, who knows, right? Healthcare has made huge progress. We've eradicated epidemics that used to kill millions, but life is fragile. People still get sick or pass away for reasons that maybe should be someday curable. What if we could improve diagnosis? Innovate to predict illness instead of just react to it. In this episode, we'll see how machine learning is combating one of the leading causes of blindness and enabling a son with a neurological disease to communicate with his family. AI is changing the way we think about mind and body, life and death, and what we value most, our human experience.
This is particularly true in India.
Sir, excuse me, konja gavaninga.
Diabetic retinopathy is a condition which affects people with diabetes. In the early stages, it's symptomless, but that's when it's treatable. So you want to screen them early on before they actually lose vision.
Dr. Kim called up a team at Google. Made up of doctors and engineers, they're exploring ways to use machine learning to solve some of the world's leading healthcare problems. The team uses the same kind of machine learning that allows us to organize our photos or tag friends on social media. Image recognition. First, models are trained using tagged images of things like cats or dogs. After looking at thousands of examples, the algorithm learns to identify new images without any human help. For the retinopathy project, over 100,000 eye scans were graded by eye doctors who rated each eye scan on a scale from 1 to 5, from healthy to diseased. These images were then used to train a machine learning algorithm. Over time, the AI learned to predict which eyes showed signs of disease.
Once you have the algorithm, it's like taking your weight measurement. Within a few seconds, the system tells you whether you have retinopathy or not.
சர்க்கரையினால கண்ணோட நரம்புல ஃபுல்லா ரத்த கசிவு இருக்கு. அது போக அந்த நரம்புலையும் நீர் கோர்த்து இருக்கு. சரிங்களா?
So you can see how AI, like in collaboration with Google, Arvind and Shankar Nethrale worked extensively, annotating more than 100,000 eyes for an algorithm to develop, and it has completely revolutionized screening of diabetic retinopathy, especially in remote areas. Now, a lot of work has also been done in cataract surgery. As we all know, cataract is surgery with the evolving technology and the techniques. There are high expectations and the associated precision that comes with it is also expected. It is evolving very rapidly to become a refractive surgery, and this demands for increased accuracy, safety, and customization. This is where artificial intelligence is going to play a very, very big role. So as the population ages, the demand for cataract surgery is also going to increase. So I was just as I was preparing for this particular presentation, when I was going through the literature, you can see that a large amount of work has already been done and reported, especially in the last few years. And why artificial intelligence in cataract surgery? Why will it be suitable? So to begin with, we have a very, very data-rich workflow. As we know, cataract surgery is the most common surgery performed worldwide. Cataract is probably the most common cause of reversible blindness. So we have huge amounts of data, which is perfect input for artificial intelligence to develop its algorithm. We already have mature models. What you saw from the video for diabetic retinopathy, we have learning models which are suited for medical imaging and tabular prediction. And we also have clear tasks, for example, grading of the cataract or predicting the IOL power. Moreover, we also have a clinical incentive. It is something which upsets a lot of patients and also the surgeons as well, is our refractive surprises. So this will allow us to minimize refractive surprises and also screen patients who require cataract surgery and refer them appropriately. So when it comes to pre-op evaluation, IOL power calculation is something which is very, very imperative in terms in bringing success to cataract surgery. So we already have multiple 5 generations of IOL formulae, and Barrett Universal 2 is something which is being universally followed. But we have artificial intelligence IOL formulae as well, which are coming up, which includes Kane and Hill RBF. They have shown to outperform the classic formulas such as SRKT, Hoffer Q, and Haggis. So they are better across short and long axial lengths with very, very fewer outliers. However, Barrett Universal 2 is still very, very competitive, very strong. Although meta-analysis have shown that Kane and Hill RBF are still comparable. So cataract grading from slit lamp images has also been being very extensively being worked upon. So this will allow for population screening in rural or low resource settings where the healthcare centers are quite far away. The challenge that is associated with it is the image quality variability. So the slit lamp camera might not be standard across the various centers or various settings, but this artificial intelligence would have learned from the quality of the images that are obtained from a particular camera. So this is one study which was done, which an artificial intelligence app, which was developed in collaboration with Arvind Eye Care system, which was called eParvai. Parvai in Tamil means vision. So it basically allowed you to, it is a mobile app which is available for Google Play Store, and it allows you to grade different grades of cataract: mature, no cataract, IMC, or a pseudophakic eye. The sensitivity was quite high, but specificity was a little low. Mature cataract and PCIOLs were not very accurate, whereas it was quite accurate for immature cataract. So it is a beginning and still requires a lot of work. Similarly, a study has also been done for artificial intelligence in using artificial intelligence cataract grading system based on logs 3, and this study showed an accuracy of 92 to 100% in the diagnosis of nuclear cataract. So coming to intra-op guidance and workflow. So as we all know that, developing countries such as India, there's a huge cataract burden. And one of the ways to tackle that, to remove, clear the backlog is through empowering young ophthalmologists and training them. So this is where artificial intelligence also plays a role. It allows you for skill assessment. AI generated performance scores have shown to correlate with human expert rating and are extremely useful for surgical training. So this was another study which was done, and where AI-powered video analysis system was used to give us to score the neutrality, the centration, and the focus which was achieved by a surgeon during the surgery. And it compared experts versus trainees, and the results were quite accurate. And obviously, it also plays a very important role in outcome prediction. So you can predict the residual refractive error, which might be there after the surgery. So you can tailor the patient expectations accordingly and do the counseling. And feedback loop is something which is, allows the AI system to improve continuously. It allows you to modify the AI constant, the surgically induced astigmatism. Probably the patient comes for review after a month, you do post-op keratometry, feed in the values, and the AI will automatically modify the formula. So coming to the gaps, so most biometry data sets are single center, device specific, and private. So if you tend to, for example, I have no financial interest here. So for example, if I have an IOL Master 700 and I developed an AI system, AI formula, which is based on that, but if someone else has, for example, LensStar, so that AI formula might not work as well for that particular biometer. So what we need is we need multicentric, open de-identified data to improve generalizability. So coming to validation, the prospective validation is needed beyond retrospective data sets. So as I already told, if new devices will come, they will tend to cause an AI drift because the AI, whatever software or algorithm that we are developing might be based on a previous machine. So this is where human AI teamwork will come into play, where human will sort of guide or correct the artificial intelligence. That is how the DR screening came up, where humans used to annotate the images, whether mild, moderate NPDR is there, and the AI used to learn from that. So coming to regulation, AI is classified as a software as a medical device, SAMD, and falls under the regulatory oversight. So the data, whatever data you are obtaining, you need consent on anonymization, and obviously there should be equity. It should be available for all, for everyone across all races, gender, and so on. So to conclude, AI is already useful in IOL calculations and surgical training. It is being extensively employed for generating scores for in training of surgeons. Already we have formulae available in biometers. However, the results vary drastically by population, and local validation is essential. So we need to cross-check wherever AI is being employed. So AI should augment and probably not replace ophthalmologists. So thank you for this opportunity. Thank you.
Thank you, Samir. We'll take comments from our international panel. A good friend again, Dr. Wei from Malaysia, followed by Dr. Sara, who has some few slides to show to us. Dr. Wei.
Okay. Hi, thank you so much, Prasanna, for inviting me, and of course, thank you, Tamil Nadu Ophthalmic Association, for this opportunity. And this is absolutely very mind-blowing, because as we know that cataract surgery is so common in ophthalmology, and Dr. Samir has already summarized lots of important pearls here. So for me, I think that the important point is, for the time being, that we can see is about the IOL calculation, as well as we know that Kane all this using AI, but Barrett's calculation is still fighting strong. But of course, with time and with more data coming in, I think maybe the calculation will be better and better with AI assisted. And of course, in terms of training, AI is really doing a very good job on, they can tell from the video, is it doing by a trainee or is it by a consultant? So of course, all this is still stopped in the software, but with times, I think we might move on to AI and robotic more, where you can see a lot of in urologists and also gynecologists, where they have these robotic arms that helping with the AI software assisting. So that could be a very exciting future. But for the time being, I think it will be very, very useful for IOL calculation and also post-op prediction. Yeah, so that's all from me. Thank you so much, Dr. Samir, for the wonderful presentation.
Thank you, Dr. Bai.
Dr.
I
Sara?
have a question.
Yeah.
Prasanna, maybe
Yes,
a very
ma'am.
basic question.
Yeah, ma'am.
So, on and off, I've been using ChatGPT. So whenever I ask for some images or anything like that, then it says, no, this does not support. Is it because I'm asking from the phone? It says like, it can't make a PPT or it can't create images. This does not support. So I'm not able to get it. Any specific reason why I'm not able to get it, or the free version is only this much, limited to this much?
You can select the model, ma'am. I think you must be on the lowest model of the free version.
Okay.
You can select the model on the top, right? You can select the model to the highest available for you.
Okay. But will the phone generate the image?
Yes, ma'am. I do most of it on the phone because
Okay.
the phone is always with you. You don't have to find the desktop or laptop. So yes, ma'am, it can work on the phone. You just have to choose the highest available model for you. Gemini also does Perplexity AI by, I think if you have an Airtel SIM, you can get that. All of them do. So what happens is I create too many images in one that it says you cannot create any more images for the next 15 minutes. So I switch over to the next AI.
That's great. Good knowledge.
You can switch over to the next app. By the time you come back, the time limit would be over.
Yeah, correct.
Come back and do it.
Thank you. That's great news.
Dr. Sara?
Yes.
Yeah,
If Dr. Niranjan could please share the slides. I apologize for not having to turn on the camera because I am traveling. I'm not in Maldives at the moment. That's why.
Okay. Niranjan, can you?
Yes, sir. Yes, sir. Just a minute.
So Dr. Sara had a quick visual PPT which she wanted to show to us from her take on the AI in cataract surgery. Niranjan, are we sharing it?
Sir, it's on Google Docs, so it's just taking a minute to load. Just a minute, sir. It's ready, sir.
Thank you so much for waiting. So while we're waiting, I just wanted to do a quick recap.
Dr. Sara, sorry to interrupt. I have it back end with me. I'm sharing the screen now.
All right.
Yeah, you can do the needful. Over to you.
Okay, no problem. Thank you so much. I will be talking about AI in cataract surgery with a lens, with a clinical operations lens, not the intraocular lens. Moving on to the next slide, I'll just do a quick recap here. Implementation in the OT can be preoperative, intraoperative, and postoperative. I will be talking about this in detail in the next slide. So if Dr. Prasanna, could you please change to the next slide? Yeah, next slide, please. Okay, so here we see the 5 pre-op uses for AI, which is IOL power calculation, which has already been discussed. So I'm going to skip this. And also IOL lens. So we have noticed that there are lower mean absolute errors. So this means that the predicted refractive outcome minus the actual post of refractive outcome is actually the mean value is much lesser when we use AI compared to the manual formulas that we use. So this shows that we actually AI is empowering us rather than trying to replace us. And in slit lamp microscopy, there's been a research done by Shimizu in 2023, which shows that the algorithm created to diagnose cataract. So diagnose and stage cataract according to the severity is actually accurate to most ophthalmologists. So we have actually diagnosed the cataract type and the stage by real ophthalmologists and also by AI. So, and then it actually gave up to 90% accuracy. And then AI is also used to triage corneal diseases. So there's two modes basically in AI. So there's a deep learning mode and a mechanical, I think, machine learning mode. So the deep learning mode is developed to triage corneal disease, so including cataract with similar accuracy to corneal specialists. Moving on to the next slide. Intra-op preparation. So we can use a smart theater system with AI in cataract surgery. So that means that we can have like a multimodal data analysis. And as mentioned before, there's speech recognition and surgical simulations by using VR is actually, I think, could be very useful for trainees as well. And intraoperatively, there's no financial interests here, but IOL Master 700 and CASIA 2. So these are two intraop devices that is used by NHS at the moment. So what they do is they give source optical it's a source optical tomographic device. So they generate the data in real time during surgery. So which means that if there's a change in the anterior chamber depth, if there's a change in the intraocular pressure, so it generates this information in real time so that we are actually able to do the surgery well and then actually prevent complications. So actually this is the next point that I'm going to talk about, which is ocular biometry also. So for example, if there's a posterior capsular tear while doing cataract surgery, we are able to know the thickness of the tear, the length, and then it will also generate suggestions. Next slide, please. So moving on to post-op application. So this is where my clinical operation lens actually comes into play. So AI can be very useful in EMR health records and also to follow up in resource optimization. So that means that because we have limited resources, we have limited ophthalmologists, limited front office staff, limited nurses, and so on. So what happens is AI can actually do this administrative work instead of us and then continue to call the patients to come for follow-up so that these patients are actually not lost in follow-up. And then we all have this problem with operating room. Sometimes an emergency might come into the OR and then there's a big, backlog of cases. Sometimes one case might get canceled. So for this particular like time scheduling and time management, I think AI could be very useful as a post-op application. And I would just wanted to highlight in post-operative complication, this posterior capsular opacification. AI can diagnose this by using the images with an accuracy of up to 92.2%. That is compared to the ophthalmologist. So the challenges I think Dr. Samir has actually highlighted and touched. So I'm going to just go on this very fast, very quickly. I just wanted to highlight that this data that is coming, that is already generated, it's coming from the Western countries, mostly from the developed countries. So actually, according to our ethnicity, our genetics, I'm sorry. So our biometry and our values are actually not represented on this data. So because of this, there's a lack of standardized deep learning matrices. So we need to establish actually a data set for the low income and the middle income countries so that we have more representation in this huge AI generations. And then just before that's all, I just wanted to mention that does any of you have any of you heard about Dr. Dora in NHS? This is an AI prompt. It's called Dr. Dora. So what this AI prompt, what it does is it has made more than 12,000 calls to patients last year. So each of these calls is about 8 minutes. So it's like, if you think about it, it's like having two nurses calling all day, every day for 1 year, just doing nothing else. So it's quite a substantial amount of time that the nurses who are working in NHS is actually delivering face-to-face care in other clinical activities, and they are more participated in the surgical clinical activities, and even the doctors are more I'm sorry, able to generate more time to actual surgical practices. So, but there is actually some positive feedback and very few negative feedback regarding Dr. Dora. So you can actually research about this in BBC. It's been on NHS News. I think it made the headlines in February 2025. So it says that compared to February 2024, there was a 35-week, I'm sorry, there was a 35-week waiting gap. But after Dr. Dora has come into play, it's been just 10 weeks. So this shows how much AI has empowered and tried to decrease the backlog of cases. So that's all. Thank you so much for giving me the opportunity to talk. It's very, very nice meeting all of you. Thank you, Dr. Prashana. And thank you to Tamil Nadu Ophthalmologic Association.
Thank you. Thank you so much, Dr. Sarah, for your eager enthusiasm in coming forward to share your perspective in the form of a PowerPoint, which is very unique. And thank you so much once again for putting in so much effort. And we would like to hear from the rest of the house a quick opinion regarding any doubts or any suggestions, any perspectives. Please
Yeah.
feel free.
Can I make a comment? Aditya.
Yes, sir, please.
Yeah, so I think the webinar was absolutely fantastic. So I learned a lot from each of the speakers, right? From John sir, who told us how to create our own AI, and Prabhu's talk was very enlightening. So I actually realized how many mistakes I was making when writing the prompts from AI. So we've also been using AI in some form in our practice. What we do is we have a AI chatbot that is actually able to communicate with patients who visit our website. So the minute patients visit our website, the chatbot comes online and it starts to speak to them. It asks them whether they want a routine appointment, cataract surgery, or refractive surgery, and it's also able to give them standardized responses like how long will the surgery take, what precautions should I take before coming for appointment, what's the recovery like. So it's able to do all of that and also fix an appointment and send that data to a reception. So we've been able to get more patients that way who are interested in refractive surgery. The other broader perspective question that I would like to ask, and it's also slightly philosophical in nature, and it's open to everybody and all the speakers and the panelists as well. So as more and more people start to adopt AI and we use it for everything, and we have perfect presentations, perfect CVs, everything which is properly grammatically correct, are we going to end up rewarding human authenticity in the future? Because as an example, just a couple of days ago, I received 2 CVs for people who wanted to join my fellowship. I could see one CV was authentic. The person had actually taken the time to write out a proper CV, and the other one was AI generated. I could see that because I most of my emails nowadays I use AI myself. So I automatically went to the person who took the effort to write their own CV, and I've asked them to come for an interview. Are we going to see this in the future where we actually reward human authenticity? I know AI makes everything seem perfect, but in general, the nature of humans is to be imperfect. So are we going to start to look at that imperfection as an advantage? So I'd like to present that question to the panelists and the speakers.
I think that's a very, very good question that I think even you can ask the AI to sounds like a human that have some mistake. I think you can do that as well, I guess.
Yeah.
Aditya, to just answer it in a philosophical way again. So
Yeah.
my project on AI was to bring human intelligence into artificial intelligence. So to create an algorithm which has human in the loop learning, where when I was with my mentor, Dr. Satyan, we built an algorithm where we trained the fundus photo, like the glaucomatologist sat with the fundus photo and drew 26 intricate signs. What is a disc? What is a cup? What is a peripapillary atrophy? Alpha, beta, RNFL defect. So, as rightly told by you, if you're going to have human arms inside, so the algorithm that we made was we had human validation as well as human inputs. So, 2 human arms were there. So I feel human intelligence incorporating it with AI, because the way AI functions, the way it is, the black box dilemma is something that we don't really understand. So having human arms in the algorithm that we are going to make, another publication we brought out in our TNOA journal last year, a bimodal AI, me and Dr. Murli Ariga sir was part of that project with UCLA. So I feel bringing human intelligence will always reward you, even if you are having AI projects. That is one. Second thing is, as you rightly told today, if there is going to be a write-up in mail or in WhatsApp, I think if you have an imperfection, it actually gives a joy on your face that
Yeah,
you have actually written it. Otherwise,
exactly. Yeah.
too many bullets, too many things, if there is no typo errors, of late I am
Yeah.
getting disappointed because
Exactly. The perfect
totally.
hyphenation, highlighting all the main
Yes,
points. So all of that we know that is AI generated the moment we see it.
totally agree with you on that point. Yeah.
Yeah.
Also, the way we speak is not exactly what the AI tells us. It uses high flowing language. So everybody knows it's AI generated, but I think we are moving towards it. Maybe another 10 years, that will become the order of the day. That will become the standard of care. So we can't avoid it. Just like all this new technology, we have to accept it and move on.
Any
But
questions?
yeah, wait, but there is a small addition to this. But if you ask and if you move towards AI for all everything, there has been research which tells that the problem solving and the creative thinking capability of the humans comes down because you're not giving the brain that thought process to kind of go through the process. And if you rely most on AI, that definitely comes down in the long run. That has actually been validated. At least that you can keep it to ourselves.
Can I make a comment, Prasanna?
Yes, please, sir. Please, sir.
So AI is going to learn from us and our inputs, but the AI will go much beyond what our inputs are. And that is where it is going to outpower us. We may not even know whether it is guiding us correctly or not. But as I think Pranesh said, there will be some references that may help us. So this is going to grow. It is you cannot control AI at all. It is going to help us a lot, and we should be knowing exactly what and how to use it properly. No, as rightly said, not at all times. It is a wonderful tool. Definitely, we are going into a different kind of life. I'm sure it is going to help us, and a great webinar. Congrats once again to all the panelists and the great speakers.
Sir, a quick comment before we close or before we have further questions. Recently, I did a lot of research on MLC in AI, medical legal aspects. So the take-home message is, in the court of law, if anything goes wrong, human is actually the one who is going to be held responsible. So whatever gadgets we have at our disposal, we have to get the message straight that you can have your own AI surgery or your robotic softwares and whatnot. But in the court of law, we need to know how to handle those things, because the human signature in the case sheet still holds true. And I think we need to make sure that we are on the top of the hierarchy and have AI as an ally rather than being on the other way around where we are going to be a slave to the AI. I think that's what most of us were trying to say. So MLC aspect and the court of law is something we always need to keep in mind. So Niranjan, any other? Yeah, Dr. Madhavi, ma'am, please.
Yeah, just to add a point and highlight what Dr. Y already told, like Dr. Aditya was mentioning right now, he's able to differentiate between the AI written version and the human version. But that is also not possible if you have actually written something with the chat GPT and you can use humanized apps. There are apps which humanizes the chat GPT versions. So that is going to make it more difficult for you to even differentiate whether it is written by AI or by an actual human. How you are realizing is because those punctuations and that extra long flowing, overflowing sentences is how you are actually differentiating. But that also will be taken care if you use the humanized apps.
Thank you, Madhavi ma'am, for that input as well. I think it's ever evolving, just like our field of ophthalmology. Over to Prasanna sir for a very unique online e-certificate distribution that has been there as a hallmark of our events. Prasanna sir.
Yeah, I'm giving it back to our President, Secretary, and our ARC Chairman, ma'am, to take over and do the certificate distribution.
So
I'll keep changing.
thanks, Prasanna. This is really a wonderful thing that you've done, and I'd like to appreciate you for that. And of course, one of the best presentations in this was Dr. John Davis Sakara, because he came from the basic, and I was able to understand quite a bit of it, and I know I can apply it even more. Particularly, for people like me, who are not so tech savvy as a younger generation, this is something very good. And congratulations to Dr. Sagara Patrej for and Dr. Amit Yadav, Dr. Pranesh Ravi for his excellent presentation as well, Dr. Ashraful Haq for his participation as a panelist, Dr. Raymond Nelson Regaldo for his panelist for his discussions, and Dr. Prabhu Krishna for his excellent presentation, a wonderful knowledge and excellent sharing also. Dr. Mia So for being an international panelist, Dr. Nan Tuong for being an international panelist, and Dr. Sami Chowdhury, once again, an excellent presentation. Learned a lot. Dr. Y. Zeng for participating as an international panelist, and Dr. Sara Yusuf. And something we learned anew was this Dora app. Very interesting. Dr. Aditya Vaman for his inputs. Dr. Anujit Paul, Dr. Madhavi Pillai, Dr. Vinod Arnachalam, once again, wonderful. Dr. Niranjan Karthik and Dr. Prasanna for their wonderful coordination and absolutely fantastic webinar.
Prasanna, I have a query. Was my signature AI generated? I didn't give it to you.
Sir, for the last webinar, you gave. So offline we'll discuss. Yeah, I think we'll take a quick group photo, requesting all to switch on the camera, Dr. Amit, Dr. Mia, Dr. Sara. And also would like to acknowledge our designer, Bala, Bala sir, who has helped a lot. We are disturbing him a lot for multiple designs. Even the Zoom backdrop that you are seeing here has been done by him. And Niranjan makes sure he's also taking care of the proofreading process. Again, most of the work has been background done by Dr. Niranjan, who has worked tirelessly for this event, along with our members of the Digital Task Force team. And Sai Numerotech for the seamless Sai sir, thank you for we don't have any technical glitches because of you. And to last but not the least, all the participants, especially our international panelists, because we know in certain countries the time is now going to hit 12 o'clock. Am I right way? 11:40. So thank you all. We can go off live, Sai sir. We can take a quick photograph.
Pranesh is there?
Pranesh.
Not yet.
Pranesh, can you
Yes,
on?
Pranesh. Yeah.
We'll take with the heart symbol, ma'am. This time.
Smile.
With the heart symbol, yeah. DC sir with the heart symbol, sir.
I'm taking the photograph.
Okay, sir. Sir, I'll take one. Once you post the symbol, sir.
Okay.
Yes. 3, 2, 1. One more, sir. 3, 2, 1. Yes. Thank you. Sai sir, are we off live?
Just a moment.